Hey, you guys, it's Miss Waite. How are you? I hope that you guys are doing well today. I sure wish I could be with you, but I made this video and I'm hoping that it works. And so let's take a few notes. Here's a warm up, just like usual. Going to ask you to go ahead and knock this out on your warm up sheet, and then we can pause this video, and then while you're doing that, and then I'll come back and we'll solve these together. All right, try them. Okay, so hopefully you've had a chance to get these done. We'll solve these equations. So remember that the idea when you're trying to solve something is to get the variable all by itself. And so you're just going to do whatever it takes to do that. And you're going to have to read each equation individually. And when we're looking at number one, we can see that our variable is almost all the way by itself. All we need to do is get rid of a 1, a positive 1. And the way you get rid of a positive 1 is by creating a negative 1. And that will create a cancellation that gets rid of that 1 from that side. But because equations always need to be balanced, you also need to do the same thing to the other side. And now we have this cancellation here, and then x equals 0 minus 1, or negative 1. And since x is all by itself, we have solved this equation. These are one-step equations, and they should be pretty familiar. Over here at number 2, the y is kind of by itself already, but we got to get rid of a negative 3. In order to get rid of a negative 3, we're going to have to add a 3. Make sure we do that to both sides. That creates this cancellation, and y equals 0 plus 3, or 3, and that one is solved because the y is by itself. And then the last one, we have x minus 3. You're going to add 3 to both sides, create this cancellation, x equals 6 is your final answer. What we're going to be doing today is a whole lot like that, except we're going to be doing it with inequalities. Before we do, though, take a moment to go over your notes a little bit. You can, again, pause this video, write yourself some questions, write a summary. You can get a new note page ready. I'm going to click it forward to the next slide before you pause so that you can get that new note page ready. Take about 4 minutes to work on your notebook. Go ahead and pause. Alrighty. So now it's time to get started on some notes. So before I left at the beginning of this week, we were talking about inequalities. And we talked about how when we're talking about equality, that's when everything is the same. One side of a mathematical expression is exactly the same as the other. It's like two ways of saying the same thing. With inequalities, we've got some differences. They're not exactly the same, and that happens a lot, and so we have to account for that. The big deal about inequalities is that it comes with the idea that you need to graph them. Because when you're solving an equality, an expression with an equal sign, there's always one answer. Well, most of the time anyway, there's one answer. But equalities have an infinite number of answers, and so we have to draw a picture of what that answer looks like, and that's graphing. And that's what you guys have done the last couple of days. You've recognized an inequality when you saw it, you graphed it, and then you've also written an inequality from a graph. And so now we're to the point where we're going to be solving one-step inequalities. Our essential question today, how can you use addition and subtraction to solve a one-step inequality? With our topic, solving one-step inequalities with addition and subtraction, is kind of right back where we started with equalities. We just started by adding and subtracting from both sides. And so that's kind of what we're up to today. You ready? Let's do it. So back when we started solving equations, we defined what it meant to solve. And you don't have to write this in your notes again, but remember what it means to solve. It means solving means that the variable has been isolated. In other words, it's on one side of that equation or inequality all by itself. It's been isolated. So we've done that with equalities. We have done one-step equations, we've done two-step equations, then we did multi-step equations, then we did equations with variables on both sides, and now we're going to take those same ideas and apply them to inequalities. We're going to start with one-step inequalities, just like we started with one-step equations. So let's explore this idea a bit. There's no need to write this part, but I just kind of want to show you what I'm talking about. So if we add the same number to both sides of an equality, does that equality remain true? We know that's true for equations with equal sign, because we've done it a bunch and it remains true. But what about equalities? So let's add a number to this little 4 is greater than 0. If I add 2 to both sides, what happens is I have 4 plus 2 is 6 over here, is greater than 0 plus 2 over here, which is 2. Is this still a true statement? Is 6 greater than 2? And of course the answer is yes. So, okay, let's try it again and see if the same thing happens. Now we have 8 is less than or equal to 11. So what if I add 3 to both sides? On this side I have 8, 9, 10, 11 is less than or equal to 11, 12, 13, 14. Well, 11 is less than or equal to 14, and so the answer is yes. It's still true. 2 is greater than or equal to negative 3. Let's add 2 to these again. Let's add 2 to both sides. 2 plus 2 is 4, is greater than or equal to negative 3 plus 2 would be negative 1, and yep, that is true as well. So it turns out it doesn't change anything. Just like with equalities, if you add the same number to both sides of an inequality, it doesn't change anything. Those equalities grow in the same way. But maybe it's different when you subtract. So let's subtract the same number from both sides and see what happens. Let's do the same thing again. We've got 4 is greater than 0 again, and this time let's subtract 2 from both sides. 4 minus 2 is 2, is greater than 0 minus 2, which is negative 2. Is positive 2 bigger than negative 2? Yep. So far we're good. What about our 8 is less than or equal to 11? Let's subtract 3 this time from both sides. Instead of adding 3, let's subtract 3. 8 minus 3 is 5. Is that less than or equal to 11 minus 3? What's 11 minus 3? Is that 8? 8, 9, 10, 11. Yeah, it's 8. And is 5 less than or equal to 8? Yeah, it is. It's less than 8. And so it fits one of those criteria. And then the last one, we're going to subtract 2 again, like we did up above, except now we're subtracting. 2 minus 2 is 0. Is that greater than or equal to negative 3 minus 2? Negative 3 minus 2 is negative 5. Is 0 greater than or equal to negative 5? Yeah, it is. It's a bigger quantity than negative 5 is. So yeah, it turns out that you can also subtract from both sides of an inequality, and it will still remain true. So what this shows us is that we can add and subtract from both sides just like in equalities, and that is good news. Because you solve inequalities the exact same way you solve equalities. Time to take some notes, y'all. So when we have this problem, 4 plus x equals 6, in order to get the x isolated, in other words, solve the equation, we would subtract 4 from both sides. Because we already know that we can subtract 4 from both sides of an equation, and that equation remains true. We have a cancellation here. X comes down, and that x equals 6 minus 4, which is 2. And there we have our solution, because x has been isolated. Now here's the good news with inequalities. At least when you're adding or subtracting, you do the same thing. In order to solve the inequality 4 plus x is less than 6, you just subtract 4 from both sides. Just like you would expect to do with an equality. We still have cancellation, x still comes down, Now this symbol, the less than symbol, will come down, and then we have 6 minus 4 is 2, and our final answer is x is less than 2. So you solve inequalities the same way you solve equalities, except for one difference, of course. The only thing we're going to do differently is graph the answer. We always graph the answer of an inequality because there isn't just one number that's the answer. There's an infinity of numbers that end up being the answer. And so we throw them on a graph so we can see what that looks like. So we have our x is less than 2, and we're going to create a number line. And we're going to put 2 in the middle because that's our critical value, the value we talked about, I don't know what day. What was that? Was that Tuesday? Anyway, we talked about critical values. And then I'm going to put one number on one side and another number on the other, and that is enough to show the solution to this inequality. Now, x is less than 2, and so remember that if you have sorry, let me say it this way. If you have a greater than or equal to and a less than or equal to, those guys are closed dots. And then you have greater than and less than, and those guys are open dots. And so since x is less than 2, we will have an open dot at 2, and everything x could be is less than 2, and so we would color this way on our number line. Okay? And that is what you will do. Both parts, the x is less than 2, and the graph becomes the solution to this inequality. Anytime you want to pause and catch up with notes, just let the teacher know. All right, let's do another one. So to solve x minus 6 is greater than or equal to negative 10, we're going to solve it the same way we would if there was an equal sign in there. Just going to graph it too, that's all. So if we're going to solve x minus 6 is greater than or equal to negative 10, remember how we drew a line before, write down our equal sign? You can do that with inequalities as well. I suggest a dash line though, so you can really keep track of what that inequality symbol is. But you can draw what makes sense to you. Now on this left side, x minus 6, in order to get rid of that negative 6, let's add 6. Let's make sure we do the same thing to both sides though. This creates this cancellation right here. We have x is greater than or equal to negative 10 plus 6, which is negative 4. And there is our solution. Now let's graph our solution. Our critical value is negative 4, so I'm going to toss that on our number line. I'm going to put a number that is smaller than negative 4, like negative 5 to the left, and a number that is bigger than negative 4, like negative 3 to the right, and then I will graph this. Notice that it's greater than or equal to, and so we're going to use a closed dot at 4. And then x is bigger than all of that, and so our arrow will go to the right. And there you have it. That's what the solution looks like. Let's do a couple more. We're going to pick up some speed. We got b minus 2. In order to solve this, we're going to add 2 to both sides. That creates this cancellation. B is greater than negative 9 plus 2, or negative 7. Throwing this on a number line, we've got negative 7 here. What's smaller than negative 7 is negative 8. Bigger is negative 6. There's going to be an open dot at negative 7 because that's our critical value and it's strictly greater. And then b is bigger than negative 7, so we'll make our arrow go that way. All right? We're getting quicker. We're doing good. M minus 3 is less than or equal to 5. You clear out that negative 3 by adding 3 to both sides. And now we have that cancellation there, and m is less than or equal to 5 plus 3, which is 8. 8 is our critical value, so I'm going to throw that on the number line. One number smaller than 8 over here, one number bigger than 8 over here. And then we're going to put a closed dot at 8 because it has that little line. It's an or equal to. And then m is smaller than 8. And so we color it this way. My arrows are the worst. Oh, well. You get the idea, I hope. I'm thinking you get the idea, even though you can't technically talk back to me right now. I hope you get the idea. All right, so let's solve this inequality and then graph it. Oh, there's my number line. So y plus 8 is less than or equal to 5 can be solved by subtracting 8 from both sides. These cancel. Y is less than or equal to 5 minus 8, which is negative 3. We're going to throw that negative 3 onto our number line. Negative 4 is smaller. Negative 2 is bigger. And so we're going to have a closed dot at negative 3. And since everything y is smaller than negative 3, we are going to color to the left. There you go. Oh, there's another one there. Let's do one more, and then we'll call it. I have a number line for this one. Oh, there it is. Okay. Maybe I'll bring that up. Maybe I won't. Maybe I'll leave it where it is. Okay. So we have negative 8 is less than 1 plus m. So in order to get rid of that 1 that's on the m side, we're going to have to subtract 1 on both sides. That creates this cancellation, the thing we're looking for. Negative 8 minus 1 is negative 9. That is less than m. So this is flip-flops from the other one. Maybe why I put it on here, because I want to point something out to you. So far, we've been coloring the arrow in the direction that the inequality points. This one pointed to the left, and so our arrow went to the left, and that happened in a couple of other places. But that is not a reliable way to know which way the arrow is going to go. Because check this out. If we know that negative 9 is our critical value, negative 9, and we know that, let's see, we've got to have a negative, I'm going to put this above because I can't see it. We got negative 9 here, negative 10 here, and negative 8 here. We're going to put an open dot at negative 9 just like usual. But what this is saying is negative 9 is less than m. In other words, m is always bigger than negative 9. And so even though this little arrow right here points to the, or the inequality points to the left, we're actually going to color to the right because m is bigger. And that's what we need to think through. Don't rely upon it, you color the direction of the inequality symbol because it doesn't always work. So think about what's happening and then draw your arrows accordingly. All right. So that's what I got for you. If this didn't work and you don't understand what's going on, maybe talk to a friend in the room. That's the best possible solution right now because you've got people in the room who get it. So talk to them. You could try the quizzes. That's your assignment. That's what you're going to do next. You're going to go to Google Classroom, click on the quizzes assignment, and just try it. I'm also going to post this video on Google Classroom, so it'll be there as well. You could potentially watch it again anytime you want. You've got some headphones. You could probably watch it in class. And whatever you do, don't worry, because if you don't get it, I'll be back on Monday, and we'll talk about it then. All right, you guys. I wish I was with you, and I can't wait to see you again soon. Bye.